This is Mrs.Jabeen, Assistant Professor of Mathematics, working in Lord's Institute of Engineering and Technology. Today in this lecture, we are going to learn one of the important topic of mathematics, specifically from the multivariable calculus, that is multiple integrals. As per my experience, I have seen many of the students feel difficulty in the evaluation of the double integral, mainly when the limits of the double integral are not given. In order to evaluate the double integral in the given region in the xy plane, they feel difficulty finding out the limits and evaluating it. So in this lecture 1, we are going to see how we evaluate the limits in the the given region in the xy plane and the evaluation of it. And in this lecture, I am going to talk about both the types of the function, that is the Cartesian and the polar functions. Okay, so before moving to the evaluation, first we are going to see the definition of a double integral. What is a double integral? Now suppose if we consider a region, we are considering a region in a two-dimensional space. Okay, take a x-axis and y-axis. I am considering a region R, which is enclosed by one or more curves, dividing this region into n sub-regions. And that regions we are denoting it as R1, R2, R3 and so on, Rn. Consider a point xk comma yk in any kth sub-region. Consider the sum sigma k is equal to 1 to n f of x comma y dkx dky. What is this dkx dky? It is nothing but the area of the kth sub-region. Now, as n tends to infinity, what does it mean? When n is tending to infinity, we have divided this region into n sub-regions. Okay. Now, if I keep on dividing these regions into infinite number of parts, see what is happening here. The area of each sub-region is reducing. Now, if I keep on dividing it into infinite number of parts, the area will shrink to a point. And if this sum tends to a finite limit, that limit we call it as a double integral. And it is denoted as double integral over the region R f of x comma y dr, or you can write it as double integral f of x comma y dx dy over the region R. Since we are evaluating it in the xy plane, we write it as dx dy. Okay. So this is the definition of a double integral. Now moving to the next, we are going to see what are the properties of a double integral. It is same like the properties what we have for the integrals. The same thing is for the double integrals also. Now here I am taking two functions, f of x comma y and g of x comma y are any two functions which are continuous in the region R. Then the double integral k f of x comma y dr can be written as k into double integral f of x comma y dr. What is happening here? Where k is some constant. So this k can be taken out of the integral and the integration can be evaluated on the function f of x comma y. Second property, we are taking two functions f of x comma y plus or minus g of x comma y. When we have two functions which are present in a sum and a difference form, you can split them up and integrate it. Okay. Third property is when we are evaluating the integral over any region, that region can be split into any number of parts. Here the region R is split into two parts, R1 and R2, and the function can be evaluated. For example, now suppose if this is the region I have, this region I can split it into two parts. I'll take the first part as the region R1 and this one as the region R2. I can evaluate the double integral in this region R1 and the double integral in this region R2. And if I added these two, I am going to get the double integral in the region R. Okay. Now next we are going to see evaluation of double integral. Now as you see, integral c to d, integral a to b, f of x comma y dx dy. Whenever we see a double integral, the first thing you have to see the limits of it. Now as we see, the limits are a, b, c, d. Okay, and see the inner derivative is dx and next is dy. So the inner integral belongs to the variable x, and as we see here, the first limits are a to b. These belongs to the variable x, and the limits c to d are for the variable y. If all these four limits are constant, the order of integration does not matter. You can integrate first with respect to x or first with respect to y. The same answer you are going to get it. There won't be any difference. The thing is that you should note the limits belongs to which variable. As I have said, a, b are the limits of x variable and c and d will be the limits of y variable. Any order you can follow. Integrate first with respect to x or first with respect to y. Now coming to the next one, as we see here, first, how are the limits? One limit is constant, that is a to b, and the other limit is f1 of x, f2 of x. So how are the limits? One limit is constant and the other limit is a function of x. So clearly it is understood that when you have the limits as a function of x, those are the limits of y. And the limits which are constant are the limits of x. Okay, so it has to be integrated first with respect to y, then with respect to x. Okay, because how are the limits of y? The limits of y are functions of x. So it has to be integrated first with respect to y. And since the limits of x are constant, that is a and b, it has to be evaluated after evaluating with respect to y. Okay. So if the limits are in such case, you have to follow the order of integration. In the previous case, what did I say? The order does not matter because all the limits were constant. But here in this case, one limit is constant and the other limit is a function of x. So here the order matters. It has to be integrated first with respect to y, and secondly it has to be integrated with respect to x. Okay, so this order should be followed. Now coming to the next type of an integral, as we see here, again one limit is a constant and the other limits are functions of y. What do you understand by this? If the limits are function of y means those are the limits of x. So it has to be integrated first with respect to x, as the limits of x are functions of y and the limits of y are constant. So this order you have to follow. First integrating it with respect to x, then with respect to y. Okay. So again here you just remember, we are going to integrate it first with respect to x, and secondly you are going to integrate it with respect to y, because the limits of x are functions of y and the limits of y are constant. Normal integration, how you evaluate the single integral? Substitute the limits. The same way you have to do it. Nothing to worry about the double integral. 2 times I have to integrate. No, only one by one. Okay, integrate first with respect to x. Put the limits. You are going to get some function of y. Integrate it with respect to y. Substitute the limits. It's nothing but a continuation of a integration. Double integral is nothing but a continuation of a integration. If you are good in integration, double integration, you will not follow, you will not feel any difficulty in it. Okay, we are not integrating both the variables at a time. One after the other we are going to integrate it. Okay, so this was when the limits were given to us. Now next we are going to see how we will evaluate the limits when the region is given to us. Okay. Now here In this slide, we are going to see the evaluation of a double integral over the region R in the XY plane. Okay. The first region I am considering as the region bounded by the lines x is equal to A, x is equal to B, y is equal to C, y is equal to D. As we know, these are nothing but the lines parallel to x-axis and y-axis. X is equal to A is a line parallel to y-axis. X is equal to B, a line parallel to y-axis. Y is equal to C, y is equal to D are the lines parallel to x-axis. Okay. Now here, this is the region R, we have got it. Now in this region, I have to evaluate the double integral. So for this, what we are going to do? We are going to consider a strip. As you see here a yellow part like a scale, that we call it as a strip. Okay, this is a strip. This strip will be fixed on, the ends of the strip will be fixed on the curves or the lines what we have. I have considered a vertical strip here. I have fixed the ends of the strip on the line y is equal to C and y is equal to D. And when I move the strip from the point x is equal to A to x is equal to B, the whole region will get covered, isn't it? If I move the strip from this end to this end, the whole region get covered. Okay. Now, by seeing the ends of the strip and the movement of the strip, we are going to write the limits of x and y. How am I moving? I am moving from left to right. How x is changing? X is changing from A to B. So with that, I am going to get the limits of x. Now as I have said, the other limits I will be getting by seeing the ends of the strip. Where I have placed the lower end of the strip, I have placed the lower end of the strip on the line y is equal to C. And where is the upper end of the strip? On the line y is equal to D. Okay. So here, how y is changing? Y is changing from C to D. Okay. Understood? How we are finding out the limits in the region R? By considering a vertical strip. Even you can consider a horizontal strip also. Here I will show you for the horizontal strip. See, instead of a vertical strip, I am taking a horizontal strip. So this is a strip. How can I move the strip? I can move the strip from down to up. So when I move the strip from y is equal to C to y is equal to D, along which axis I am moving? I am moving along y axis. So with that I am going to get the limits of y. How are the limits of y? The limits of y are changing from C to D. And where I have fixed the ends of the strip, the first end of the strip I have fixed on the line x is equal to A, and the other end of the strip I have fixed on the line x is equal to B. With the ends of the strip, I am going to get the limits of x, that is nothing but A to B. Okay. So in this region, it was possible to take the strip, both the strip, the vertical strip or a horizontal strip. You will get the same limits, and when you evaluate with this, you are going to get the double integral over the region R, which was bounded by these four given lines. Okay. Now coming to the next type. Now suppose if the region R is bounded by the lines x is equal to A, x is equal to B, and some curves y is equal to f1 of x, y is equal to f2 of x. So here what is given to us? Two lines are given to us and two curves are given to us. So first thing what we have to do, we have to plot these in the xy plane. So when I am plotting these in the xy plane, the line x is equal to A, x is equal to B, and the curves y is equal to f1 of x, y is equal to f2 of x. Now see here again what I have considered here. I have taken a vertical strip. Okay. This vertical strip where I have fixed the vertical strip. The lower end I have fixed on the lower curve, that is y is equal to f1 of x, and the upper end of the strip I have fixed on the curve y is equal to f2 of x. And from where to where I'll be moving the strip? I'll be moving the strip from x is equal to A to x is equal to B. So if I move from this end to this end, the whole region will get covered. Okay, the whole region R will get covered. So with these, by seeing the movement of the strip and by seeing the ends of the strip, we are going to write the limits of x and y. How x is changing? X is changing from A to B. And to get the limits of y, what should I see? I should see the ends of the strip. Where I have placed the ends of the strip, the lower end of the strip is on y is equal to f1 of x. And the upper end of the strip is on y is equal to f2 of x. So with that I am going to get the limits of x are A to B and the limits of y are f1 of x to f2 of x. Okay. Now here, as in the previous case, I have said that both the strips are possible. I can take a vertical strip or a horizontal strip. The region is going to get covered. But in this region, I have specifically taken a vertical strip. Why not a horizontal strip? So let us see, in this region, can we consider a horizontal strip? Yes, we can consider a horizontal strip. But the thing is that, now see, this is the region you have. Okay. When I take a horizontal strip, what will happen? The horizontal strip will come and stop here. The same way, it will come and stop here. These curved parts will be left out. No doubt, you can split the region. This region, whatever the region you have, you can split the region into three parts. As we have seen in the properties of a double integral, there we have seen the region can be divided into number of parts and it can be evaluated. Here also, if you want to consider a horizontal strip, you can divide the region into three parts, R1, R2 and R3, and evaluate it. Okay, it will be a hectic process. Instead of going for a horizontal strip, if you take a vertical strip, that can be done only in one step. You can evaluate the double integral over the whole region at a time. If you are going for a horizontal strip, then you have to divide the region into three parts, R1, R2, R3. Okay, that will take a time as well as it will be a hectic process. Okay, so it's better we consider a vertical strip in such type of regions. Okay, now moving to the next, we are going to see the region R bounded by the lines y is equal to c, y is equal to d, and the curves x is equal to g1 of y, x is equal to g2 of y. Again the same way, first thing what we have to do is we have to plot the region in the xy plane. When you plot this region in the xy plane, as you see over here, we have the lines y is equal to c, y is equal to d, which are the lines parallel to the x-axis, and the curves x is equal to g1 of y and x is equal to g2 of y. I have considered a strip here, the yellow part you can see, okay, and I have taken a horizontal strip here according to the region what I have got it. This is the region where I have to evaluate the double integral. I have taken a vertical, the horizontal strip. How I'll be moving the horizontal strip? From down to up. That is from y is equal to c to y is equal to d. If I move the strip, the whole region will get covered. And where I have put the ends of the strip, the first end of the strip I have placed on x is equal to g1 of y, and the other end of the strip I have placed on x is equal to g2 of y. So by seeing the movement of the strip, that is from down to up, I will be getting the limits of y, and by seeing the ends of the strip, I will be getting the limits of x. Okay, so as we see here, the limits of x are g1 of y to g2 of y, and the limits of y are c to d. Okay, so here again the same way, when you evaluate it, you have to keep in mind the order of integration. First it has to be integrated with respect to x, then it with respect to y. Okay, so this was the evaluation of the limits. How to find out the limits if the region is given to us bounding by some lines or curves. Okay. Again the same case over here. In this region, I have considered a horizontal strip. Instead of a horizontal strip, if I want to consider a vertical strip, again I get the same thing. How we had in the previous case, the strip will come and stop at these ends. Okay. So what is happening here? The curved parts are left out. So to cover these curved parts, I have to divide the region into again 3 parts. So see here, you have the regions. Okay, let us draw here again. I have the lines and I have the curves here. Okay, so if I want to consider a vertical strip, I have to divide the region into 3 parts. This will be the region R1, R2 and this will be the region R3. Okay. So instead of dividing the region into 3 parts and evaluating the double integral in these 3 parts, we can consider one single horizontal strip and we can find out the integral over the whole region R. Okay. So this was the function of a Cartesian form f of x comma y. Now next we are going to see the evaluation of the double integral in the polar region. Previously we have seen the Cartesian function f of x comma y. Now we will be seeing for the function in the polar region, that is f of r comma theta. Okay. Now again the same way over here, whenever you see the evaluation of a double integral, always look at the limits. How are the limits given to us? Here as you see, the limits are theta 1, theta 2, r1, r2. If all the 4 limits are constant, as I have said before in the Cartesian form, the same is followed for the polar form also. If all the limits are constant, the order of integration does not matter. You can integrate first with respect to r or first with respect to theta. In any way you can do it. Okay. Now coming to the next one, see the next integral what we have. One limit is theta 1 to theta 2 and the other limit is f1 of theta, f2 of theta. That means function of theta. Function of theta means it is understood that these are the limits of r. So if the limits of r are functions of theta, that means it has to be integrated first with respect to r, then with respect to theta. The limits of theta are constants. So here in such case, the order of integration matters. Integration with respect to r should be done first and secondly you have to integrate it with respect to theta. Okay. Now we will see how to evaluate the double integral for the polar region. Here I have taken a region which is bounded by some radial lines. Theta is equal to theta 1, theta is equal to theta 2 and the curves r is equal to f1 of theta, r is equal to f2 of theta. The same way how we have plotted the region, here also in the polar region you have to plot the region. So for plotting the region, I have drawn the radial lines. Theta is equal to theta 1 and theta is equal to theta 2 and the curves r is equal to f1 of theta, r is equal to f2 of theta. So this is the region we have got it. And remember in the polar region we have to consider a wedge. Wedge is nothing but strip like only, but one end of it will be pointed and the other end will be broad. In the previous case, in the Cartesian form, we have considered a strip. The strip is scale-like, whereas the wedge, one end of it will be pointed and the other end will be a broad. The pointed end should be fixed at the pole and the broad end should be fixed at the curve, on the curve. Okay, and you have to move the wedge in such a way that it covers the whole region. Now see here, I have fixed the wedge. One end of the wedge I have fixed at the origin and the other end of the wedge I have fixed on the curve r is equal to f2 of theta. If I move my wedge from theta is equal to theta 1 to theta is equal to theta 2, the whole region is going to get covered. Okay. So again here, to get the limits of r and theta, I'll be seeing the ends of the wedge and from where to where I am moving the wedge. Okay. So since I am moving my wedge from the line theta is equal to theta 1 to theta is equal to theta 2, the limits of the theta will be nothing but theta 1 to theta 2. And to get the limits of r, see here where I have placed the first end of the wedge, the pointed end at the origin, and the other end I have placed on this curve. But do I need this part? No, I don't need it. I need it only from this curve to this curve. So I'll see where is the first end of the wedge and the second end of the wedge on the curves. Okay. So the limits of r will be nothing but, as the first end of the wedge is on f1 of theta, the lower limit of r will be f1 of theta and the upper limit of the r will be f2 of theta. Okay, so with this we get the limits of r. Okay, so here you have to remember, in the polar region you have to consider a wedge, whereas in the Cartesian form we have considered a strip, either a vertical strip or a horizontal strip. Now next we are going to consider an example here. I have taken a problem over here. Evaluate double integral dx dy over the region R bounded by some curves are given to us. Y square is equal to 4ax, x square is equal to 4ay in the xy plane. Okay. So first thing what we have to do is we have to plot the region. Plot the curves, get our region. In that region we will decide which strip we have to consider, either the vertical strip or the horizontal strip, and obtain the limits of x and y. Once we get the limits of x and y, easily we can evaluate the double integral. Okay. So as we see here, what curves are given to us? Y square is equal to 4x. As we know, it's nothing but a parabola which is symmetric about the x-axis. So I have drawn a parabola. Y square is equal to 4ax which is symmetric about the x-axis. Next we have x square is equal to 4ay which is another parabola which is symmetric about the y-axis. Okay. Now I see a region which is bounded by these two curves. So this is our region. Once we get our region, we have to mark the points of intersection. Where they are intersecting, one point is the origin, the other point we are getting 4a comma 4a. That is, if you solve these two equations, you are going to get this point of intersection. Okay. Now here in this region, this is our region. I have considered a vertical strip. Okay. This end is 0 comma 0 and this is nothing but 4a comma 4a. Okay. When I move the strip from 0 comma 0 to 4a comma 4a, how am I moving? I am moving from left to right. On which axis I am moving? I am moving on x-axis. So with that I am going to get the limits of x. How x is changing? X is changing from 0 to 4a. So with that I have got the limits of x are 0 to 4a. Now to get the limits of y, what should I see? I should see the ends of the strip. Where I have placed the lower end of the strip? I have placed the lower end of the strip on this curve. What is that curve? X square is equal to 4ay. From this, what I need the limit of y. So I will be obtaining the value of y. What will be y from this equation? Y is nothing but x square by 4a. So with that I will get the lower limit of y. Now to get the upper limit of y, what should I see? I should see the upper end of the strip. Where I have placed the upper end of the strip? On this curve. What is that curve? Y square is equal to 4ax. In this what I need? I need the value of y. So to get the value of y, what should I do? I should take the root on both the sides. If I take the root on both the sides, what I am going to get? 2 root ax. So the upper limit of the y also I have got it. That is 2 root ax. Clear here? So these are the limits of x and y. After getting the limits of x and y, whatever the integral is given to us, that is double integral dx dy, you just place the limits and decide with respect to which variable you are going to integrate it. See what kind of limits you have got it. With respect to that, you are going to decide with respect to which variable you are going to integrate first. As you see here, the limits of y are the functions of x. So it has to be integrated first with respect to y, then with respect to x. Okay. Now see the evaluation here. I have placed the limits. These are the limits of x and these are the limits of y. So I am integrating first with respect to y. When I integrate it with respect to y, any function is given to us, nothing is there. That means 1. Integral of 1 dy is nothing but y. Limits, apply the limit, upper limit minus lower limit. Simplify it, then you have to integrate it with respect to x. When I integrate it with respect to x, substitute the limits of x, you are going to get the answer. Okay. Going back, see here, as I have said, I have taken a vertical strip. You can even take a horizontal strip also in this region, because the horizontal region is also, the horizontal strip also is possible in this. Now for the horizontal strip also, I'll show you what kind of limits you are going to get it. You can evaluate the same problem with the horizontal strip limits, what we get it, the same answer you are going to get it. Okay. So see how the strip will be moving. The strip will be moving from down to up. Down to up means how am I moving? I am moving along the y-axis. So when I move along the y-axis, I have to see how y is changing. How y is changing? Y is changing from 0 to 4a. So with that I am going to get the limits of y is changing from 0 to 4a. And to get the limits of x, what should I see? I should see the ends of the strip, where I have placed the ends of the horizontal strip. Where is the first end of the strip? On this curve. What is that curve? Y square is equal to 4ax. From this what I need? I need the limit of x. To get the limit of x, what should I see? What will be the value of x from this curve? X will be nothing but y square by 4a. With that I will get the lower limit of x. Now to get the upper limit of x, what should I see? I should see the ends of the strip. Okay, the second end of the strip. Where I have placed it? I have placed it on the curve x square is equal to 4ay. From that x will be what? X is nothing but 2 root a y. Okay, so these are the limits I have given you with respect to the horizontal strip. I have done the problem with the vertical strip and I am giving you the limits of the horizontal strip. Try to evaluate the double integral with these limits and check your answer. The same thing you are going to get it. Okay, and while evaluating, remember that it has to be integrated first with respect to x, then with respect to y. Just the order of integration will change here, nothing else. In this session, we have seen the evaluation of the double integral when the limits were given to us and the region given to us. How we evaluate find the limits of x and y. Okay, both in the Cartesian and the polar form we have seen, and we have seen one example also. In the coming videos, we will be seeing the evaluation of the double integral for the polar functions also, and even the evaluation of the triple integral, how to evaluate the limits of a triple integral in a three-dimensional space. Thank you all for watching. Don't forget to like and subscribe our channel. Thank you.